In this video, we are going to explore something really fascinating in deep learning. That is uncertainty estimation using Monte Carlo dropout in multi-class image segmentation. But that's not all. We'll compare two cases. First, a model where we dynamically add dropout after training. Second, a model that was trained with dropout from the beginning. This will give us deeper insight into how much dropout during training really matters for uncertainty estimation. Now, our next interesting question is why uncertainty matters. When a deep learning model makes a prediction, how do we know how confident it is? In many real world applications like medical imaging, self-driving car, just having a segmentation mask isn't enough. We want the model to tell us, here I am confident and here I am unsure. You better check manually. This is where uncertainty maps come in. They show us how confident the model is at each pixel. Next, what is Monte Carlo dropout? So we use this simple but powerful trick. So what we do, instead of disabling dropout during inference, like we usually do, we keep the dropout on and pass the same image through the model multiple times, say 20 times, 50 times, 100 times. With each pass, give us a slightly different prediction because different neurons are randomly dropped. We then average the prediction for the final output and we compute the standard deviation for the uncertainty maps. So this gives us pixel wise uncertainty visualized as heat map. Next, the two approaches which we're going to use in this video. First approach, inject dropout layer after training. So here we take a pre-trained unit and insert dropout layer dynamically in the decoder, especially after ReLU activation. Then we run Monte Carlo inference to estimate uncertainty. In the case 2, train the model with dropout. In this case, we modify the unit architecture itself, adding dropout layer inside the decoder while training. So the model learns to be robust even when some neurons are randomly turned off. So here we are in our code, and now we'll start with our coding part where we dynamically add the dropout layer in our pre-trained unit. So first of all, we are going to import all the libraries which we require for this task. After that, we have a function that is called add dropout to the decoder, as you know, where we'll dynamically add the decoder in our pre-trained unit. So this function is really essential in itself. So here you can see we basically inject the dropout in our D1, D2, D3, D4, and specifically after each ReLU layer where we have a dropout rate of 0.5, that is 50% neurons would be turned off. So this is a really quick method where you already have a trained model, everything, so you don't need to change, just add this and things are done. So after that, we have our few functions which we already have in our previous video, so I won't explain them much. So this is another function where this function basically convert your index mask to RGB. I don't think we need it here. I don't think we need it here. So now comes our main function, that is MC dropout inference, Monte Carlo dropout inference. So this function is really simple in itself. What this does, it takes your model where we have load the weight. Then you take your image tensor, then we have a value t. So t basically refers to how many times we gonna give the model the image and get our results. Okay, that is t value. You can increase it further to 50 or 100 according to your work or your uncertainty estimation. You can check different values for it, but for this video I'm going to keep a value of 20, and I think that's enough. So here what we do, we say with torch.noGrade because we don't want to train it But remember here the model is still in training phase. We want, this is because we have done this because we want to make sure the dropout layers are still working, because if you put in eval phase, the dropout layer won't work. But we specifically need for this Monte Carlo dropout, we want the dropout layer to work, so that when each with each for loop here, we give our image tensor and we get a slightly different prediction. After that we pass it the prediction to softmax and we get our uh, prediction or the probabilities. Then we add those probabilities to our list. Now when the loop is done, after that, to calculate the mean prediction, we calculate the mean of all the prediction, and to calculate the uncertainty estimation, we have the standard deviation of all those 20 predictions. Okay, here you can see we take the predictions and calculate the standard deviation. So in this way we get the mean prediction and the uncertainty estimation. So this standard deviation is basically the uncertainty estimation. So now you might be asking question, why do we need to give each image multiple time and dropout? Because what dropout does, it randomly dead few if you fix amount of neurons, in our case 50%. So when some neurons are off, so we want to see what prediction our model gave us. If it is same, so we can say model is fully sure. If it is different, then we can say our model is not certain about some area or some region or some mask or some specific thing inside our image or the model inside the mask, that this area he is not sure about. So that's why we iterate it over 20 times, 50 or 100 times. So this is the main function. After that I'll copy the entire thing again. Now we have a main function called run uncertainty. I'll explain. Let me turn this on. Yeah. So now here what we do, here run inference. So it takes your model, then test images. It does not take your ground truth. That's the best thing here. Then the size, because we need to resize the image, color map. Then we have saved dir, the folder where we're going to save this uncertainty map, and t, basically the value. It tells how much time we're going to iterate the same image and give it again and again to the model. So we loop over the entire image path. We first extract the image name, then we read the images RGB, resize it and save it, save a copy of it. Here we pre-process the image so that it can be fed to the PyTorch model. So you can see we convert it to a channel first, then we normalize it, we expand it dimension, convert to float 32, then we convert this numpy represent to a torch tensor. After that we give it to the MC dropout inference function to get our mean prediction and the uncertainty map, uncertain in these standard deviation probabilities. Okay, now to get the prediction mask, we use our mean probabilities from the softmax function, and we what we do, we apply a argmax function to we get our predicted mask, and over the standard deviation probabilities we calculate a mean of them and we get our uncertainty map. Next we normalize the uncertainty map, and then we apply heat map, that is color map jet. This is the same color scheme we use for the grad cam, and most of the heat map work we usually use this. Next we convert the predicted mask which is an index mask form where values are 0 to number of classes. So we're gonna have three values as 0, 1 and 2 to a RGB mask which has these specific RGB values. Next we save these prediction and the heat map. Okay, so this is really simple, and now we're gonna work on the execution part. We're gonna execute it. Yeah, So first of all, we seed the environment, make sure the randomness is same every time, because we know in deep learning we have random weights and something, and really these things assign. So we want to make sure we seed the environment. Then we have some configuration, image height and width, then the data set path, then we have this color map, then number of classes, and here we load our model. Can see we have our, we check whether we have CUDA or not. If CUDA, we're going to use that, otherwise we're going to run everything on CPU. I have an RTX 3090 which I use for everything, my research in deep learning and other sort of thing. Here we load our model and we put it into our CUDA. Then here we load the pre-trained weight into our unit, and after that we add the dropout layer with 0.5. maybe you can also play with this value 0.1, 0.2 to 0.9 also, I will say, just try to play with it. Then we load our data set here and we create proper folders, that is a joint folder and uncertainty. So joint would save joint image where it is original image, prediction and the heat map, and in the uncertainty folder we'll save only the heat map. We create those folder and run this uncertainty. So what I'm going to do, I'm going to run this. This is without training. Yeah. Then we're going to run this uncertainty. Yeah. So it's going to take few minutes. So I'll come back later. So we are done now. We can now see the results. What do we have? So the joint folder, we have joint images, image prediction and the heat map. Okay. Now we also, you should also understand what each color mean in this heat map. So we can say that red/orange or red orange basically mean high uncertainty. Yellow to green greenish color means moderate uncertainty. Blue simply refer to low uncertainty. So we can say in where the blue is, model is confident. So you can see multiple heat maps, and from each heat map we can observe one thing is for sure. So we can easily see that the background is shown in blue is where the model is most confident, but in the regions where V1 and V2 are there, we can see orange red patches. This means model is less certain about classifying these pixels, which makes sense given the complex texture and plant overlap in these areas. So now what we have done, we have trained our unit model with dropout layer in it, and now we again going to run this uncertainty file to see the difference between both the heat maps. First, where the model is not trained with dropout and we have dynamically inserted the dropout layer in it. Second, in the second case, we have trained our model with dropout layer, so the model is robust enough to know that these some neurons can be dead or off at any time, so it should be robust enough to comprehend that situation to work in that case. So let's again run this uncertainty file. So let's wait. So again our loop is complete and we can again see the uncertainty results. Okay, now this time we can clearly see the difference between the image. Now here you can see we have more blue part. I hope you can clearly see the difference. Now we can say that with this part the model is truly confident that this is this specific class, while this red and orange yellow color, the model is less confident. So now this is looking really good. Okay, now again the same case. So we can easily see the difference between the heat maps before the training and after the training. So after seeing both the approaches, I can easily say that use dropout in your network so that in your work you can use this Monte Carlo dropout and show as uncertainty maps, maybe in your research paper, in your projects, or anything which you are working on. So this uncertainty map really helps you to show where your model is more confident and where it is not. And also from a reviewer, another person point of view, this is kind of, we know that our model is now not that black box. At least we know what is inside those layers. So we know you can use, like from my previous video we have grad cam, now another technique, this uncertainty estimation using Monte Carlo Dropout. So they really help, and even I'm happy to see the result. We have bluish color everywhere. I'm really happy to see that blue color and less of red and yellow. So I hope you also getting a little happy after seeing the result, that now we can say that model is more confident. So now it's time to combine both the images and see the result. So I already have a script. Here we combine both the image. So let's go out and run combine. Okay. So what I combine is I take the this without training joint mask, okay, and I join the heat map from with training. Result this uncertainty. So it is individual. So I do so that we can easily see where it is, where it is, where it is. Okay, where. Sorry, it's kind of mistake. I have joined the same image. Okay, so let me just check my mistake. And so these mistakes are common. Actually this happened because of this autocomplete. This is auto completed automatically. I haven't given anything to it. Without train, with train, without train, and now we have read both image 1, image 2, combine image 1, image 2. What is the error? This shit. This autocomplete is shit. I'm again telling you. I just hate this autocomplete shit, because it autocomplete without any sense. So with training, result uncertainty and invalid uncertainty. Yeah, this is the result. Like this shit makes me like, why autocomplete? Why do you need? We need autocomplete just for small things, not entire line of code. Okay, let's forget this and check. Okay, now just see the image and the two heat maps. So you can clearly see the difference between both the heat maps. When you train your network with dropout and then use those dropout layer for Monte Carlo dropout and uncertainty. So you can see training your network with dropout layer give you better uncertainty maps. So you can easily see which mask or which class the model is more confident and where it is not that confident. So now we can easily, if we analyze all the images and all these uncertainty heat map specifically after training, so you can easily see that in this specific, so you can analyze that this part and this part in this way. So easily we can analyze and say that this specific mask or class is kind of not training good. So maybe we need to increase our data set, or maybe we need to add more hard example. Now what's next? First of all, what you can do is you can add the dropout layer in the encoder and the bottleneck layer also. As you can see in this video, I have only added dropout layer in the decoder block. So try that also, and also play with the dropout value. I've used 0.5. Maybe you can do few experiment from 0.1 till 0.9 and explore more and see which value works best. And also you can try to increase the number of inference sample, that is that specific t value which I have set 20 in this video. Maybe you can try 50 or 100. Just see. But my idea is basically explore. And last, I would recommend, from the result we can also see that it's better to train the model with dropout than dynamically insert them after training. So that won't give you a much better estimation maps. Trained model which are trained with dropout layer have better uncertainty. So I hope this video give you a nice idea of how to use Monte Carlo Dropout for segmentation and how training with dropout can significantly improve the uncertainty estimate. So if you like this, don't forget to like, comment, let me know what you would like to see next, and subscribe for more deep learning tutorial. Thanks for watching, and I'll see you in the next video.